Welcome to Math 31. These are a series, or this is a series of review type questions. I'm calling them review questions, but in fact they really take what we know, give some variety and some challenging problems that we can apply our skills, and all in the setting where you're not given any direction as to what would be the best method to solve them. Now this one is a bit of a nasty problem. It looks innocent enough, with possibly the exception of those exponents. But we want to find x coordinates on this function where the tangent line is perpendicular to 2y plus x is equal to 7. Now when we take a look at 2y plus x is equal to 7, if you did isolate the y, and I'm going to do this in one step, this would be equal to negative 1/2 x plus 7 over 2. So therefore this one has a slope of negative 1/2, meaning that the slope of the tangent line will therefore be equal to, or the line perpendicular to that would be equal to positive 2. So therefore dy dx is equal to 2. So we know what to do with this problem. The next step would be to find the derivative. So we take a look at dy dx, and you have maybe a couple choices. Some of you might prefer to factor out an x term, and that would work, but normally if it's in a simple term-by-term setup like this, you want to work with it instead. Oops, and I wrote this as dy dx. Of course, that's just y. Now when I take the derivative, dy dx, I will get 5/3 x to the 2/3, subtract 1 from the exponent, plus 1/3 x to the negative 2/3. Now we have choices. We could replace the y with 2 right away, and etc. like that. But what I'm going to do is hold off with that, and I'm going to put this derivative into a different form. And I'm going to then see what I can do with it. So first off, 5/3 x to the 2/3 plus 1/3 x to the positive 2/3 on the denominator. And I'm going to now get a common denominator between those terms. Now this is a step that we haven't really used yet. Well, not with these fractional exponents at least. And we will later on when we start getting into graphing particularly. We'll see a lot of this for reasons that will be clear later on. And if we did get a common denominator with this expression, dy dx, we would have to be aware that the factor of 3 is common to both, so there's one thing. And then we also have an x on the bottom, and x to the 2/3 would be the value, the exponent for x would be 2/3 for the common denominator, which means the second term, 1, will stay as is. But this first term, which is 5, x to the 2/3, we have to multiply that by x to the 2/3. And we do that, and we'll get x to the 4/3. Now we replace the dy dx with 2. So 2 is equal to 5x to the 4/3 plus 1 all over 3x to the 2/3. So a common denominator was found. And then if we clear our fractions by multiplying by both sides by 3x to the 2/3, we'll get 6x to the 2/3 is equal to 5x to the 4/3 plus 1. Now, before I bring up the next screen, I'm going to remind you that we didn't have to do it this way. We could have taken the dy dx, not got a common denominator, made it equal to 2, and then cleared the denominators. That would have been fine. But I'm going to stick with this method. And then I'm going to bring everything over to one side, the right side. So 0 is equal to 5 x to the 4/3 minus 6x to the 2/3 plus 1. And what makes this question difficult, and it's a sort of one that if you just saw this, you came across it in your travels, you might struggle with it. What makes this one difficult is that this is actually a quadratic form. I'm just going to make sure I wrote that down right, which I did. This is a quadratic form, and so factor as a quadratic trinomial, or trinomial quadratic. And you could make a substitution. Some people do. But I'm going to break it down like this. I'm going to take that first term and note that it would break down into 5x to the 2/3 times 1x to the 2/3. So just as a regular quadratic. Now, I'll show you the substitution afterwards if you prefer. And then I break this 1 down into 1 times 1, and both of those terms would be negative in order for them to multiply outright. So this becomes 5x, when you cross and check, 5x to the 2/3 negative plus negative 1x to the 2/3. So that's negative 6x to the 2/3. So it adds up right. And it means that this is going to factor 0 is equal to 5x to the 2/3 minus 1 multiplied by x to the 2/3 minus 1. Now, had you made a substitution, you could have just picked a variable like a and made it equal to x to the 2/3. And therefore, if this worked better for you, you'd get 5. Now, you have to be careful because x to this would become 5a squared minus 6a plus 1. So you'd have to note that x to the 4/3 is equal to x to the 2/3 to the exponent of 2. A little tight there on the right side, but that's the way it would work. So it's a specialty case. And then 5x to the 2/3 minus 1 is equal to 0. Will give you 5x to the 2/3 is equal to 1. And then x to the 2/3 is equal to 1 over 5. And then by raising both sides to the reciprocal, 3/2, we would get x is equal to 1/5 to the 3 over 2. Now this could also be written as 1 over 5 to the 3 over 2. And then the other one works out much cleaner. So x to the 2/3 minus 1 is equal to 0 means that x to the 2/3 is equal to 1. And then when you raise both sides to the 3/2, you just get x is equal to 1. So these are the two x coordinates as exact values that would give you that slope of 2 for the tangent line. Tricky question, a special case because of that quadratic form that we had. Let's take a look at the next one. Differentiate. Now we go after these ones, which are just regular differentiation problems. This one's not so bad. You put it in the proper form. And by the way, stop me at any time and do it yourself and compare answers. I'm going to write this as 2 minus x over 2 plus x to the 1/4. And then this, to me, would be a chain rule first, followed by the quotient rule. Some of you may prefer to distribute that 1/4 in or to use the power rule on it. So it's 2 minus x to the 1/4 divided by 2 plus x to the 1/4. And then you could use the quotient rule and then the chain rule if you preferred. But I'll stick with this. I find it works well. dy dx is equal to 1/4 multiplied by 2 minus x over 2 plus x to the negative 3/4 multiplied by the derivative with respect to x of 2 minus x divided by 2 plus x. And this is where the chain or the quotient rule comes into play. So u is equal to 2 minus x. U prime is equal to negative 1. Remember, I'm writing this as u prime and v prime, but I'm aware that I'm actually taking du with dx with respect to x. So then v is equal to 2 plus x. So v prime is equal to 1. So therefore, y prime is equal to u prime v minus u v prime over v squared. So y prime is equal to negative 1 times v, 2 plus x, minus u, which is 2 minus x times v prime. So that's 1 times 2 minus x, all over top of v squared, which is 2 plus x, to the 2. Y prime is now equal to, when you clean up that numerator, negative 2 minus x minus 2 plus x, all over 2 plus x squared. Therefore, y prime is equal to negative 4 over 2 plus x to the 2. So make sure you've got it set up properly, and then we're really in the final stages, except for any simplification that needs to be done, because we can substitute that back in pretty quickly. Now the issue is going to be, as I see it, making this into its simplest form, because currently we'll get dy dx is 1/4 multiplied by 2 minus x over 2 plus x to the negative 3/4 multiplied by negative 4 over 2 plus x to the 2. And we do get a break on this one, or so it appears. The 4's should cancel out. Divide by 4, leaving you with negative 1. The next issue is what we're going to do with those, those common factors, or those factors that can be simplified. Because now that 2 minus x to the 3/4 isn't going to really do much with us, but 2 plus x, we have 2 plus x to the negative 3/4, and then 2 plus x squared. So those can be simplified. So dy dx will be equal to, the 4's are gone, we have a factor of negative 1, and we have 2 minus x to the negative 3/4 on top, and then the denominator is going to be, we have 2 plus x, and we have negative 3/4 for the one factor, and then multiplied by 2 plus x to the 2. And then we add the exponents. So be careful with that. If you get a common denominator, 2 would be 8 over 4. And then I think I've got enough room here for us, so I'm going to put it down a little tight, but I should be able to sneak it in there. dy dx is equal to negative 2 minus x to the negative 3/4 all over top of 2 plus x. So when you go negative 3/4 plus 8 over 4, you should get 5 over 4. Now, this can be written with the negative exponent taken to the bottom, that 2 minus x. I'm going to keep it in this form simply because I don't have enough space. So you could have also written it as negative 1 over 2 minus x to the 3/4 times 2 plus x to the 5 over 4. So that's, it's a little messier because of the fractional exponents, but, the method is the same. And had you done it a different method, you should end up in this case with the same answer. So let's take a look at a few more. Now this one I'm not going to do. I'm going to skip a couple of these just for time because we've dealt with a few of these already. And I think actually this one is in the textbook, or we did it before. So I'm going to hold off with that one. This one, though, is a good question. Y is equal to root x times root x plus 1 times root x plus 2. So y is equal to, in exponential form, x to the 1/2 times x plus 1 to the 1/2 times x plus 2 to the 1/2. And this is a form of the product rule, but where we have three factors. So to the side, I'll go u is equal to x to the 1/2. So u prime is equal to 1/2 x to the negative 1/2. And then v is equal to x plus 1 to the 1/2. And v prime will therefore be equal to 1/2 x plus 1 to the negative 1/2 multiplied by 1. So the derivative of x is just 1. So I'm going through these ones fairly quickly if they're simple. And then w is equal to x plus 2 to the 1/2. So w prime is equal to 1/2 times x plus 2 to the negative 1/2 times 1. So that would stay the same. And y prime is equal to u prime v w plus u v prime w plus u v w prime. So we substitute everything in, and y prime will give us 1/2 times x to the negative 1/2 multiplied by v, which is x plus 1 to the 1/2, times w, which is x plus 2 to the 1/2, and then plus u, which is x to the 1/2, v prime, which is 1/2. I'm going to put the 1/2 in front, x plus 1 to the negative 1/2, times w, which is x plus 2 to the 1/2, then plus u, which is x to the 1/2, times v, which is x plus 1 to the 1/2, times w prime, which is 1/2, again put the 1/2 in front, and then x plus 2 to the negative 1/2. So not looking too good yet. Do what we always do in these cases, which is take out a common factor. And the common factor, we should be able to remove a 1/2 from everybody. Then the x terms take out the lowest exponent, which is negative 1/2. The x plus 1, you'll see that somewhere we have a negative 1/2, so we take that out. And then x plus 2 to the negative 1/2 would be removed. And then, when we divide that, for the first cluster, that will cancel out the 1/2, x to the negative 1/2, and we'll be left with x plus 1. Now watch your exponents carefully. You've seen this many times, but 1/2 minus negative 1/2, 1/2 plus 1/2 is 1. And then same thing with your x plus 2. Subtract the exponents and you just get that. And then the second term, the 1/2s go away, but we just have a factor of x left over, 1/2 minus negative 1/2. And then x plus 1 to the negative 1/2 goes away, but we're left with x plus 2. And then so on. The next one, the 1/2 goes away. We have just x. And then we have x plus 1 to the 1, because the second term, x plus 2 to the negative 1/2, disappears. So now we just mop up in the middle. We get x squared plus 3x plus 2 plus x squared plus 2x plus x squared plus x. And then get the like terms together would be 3x squared, and then 3x plus 2x plus another x is 6x, and then 2 will go there. Now, you could try to factor this. But I don't think you're going to have much headway with it. You can try going 3x and x, and then 2 and 1, but it's not going to work out to add up to 6. Also, you can't take a common factor out. It doesn't look like anywhere, so it seems like we're stuck. So y prime is equal to 1/2 x to the negative 1/2 times x plus 1 to the negative 1/2 multiplied by x plus 2 to the negative 1/2. Now I'm going to, because I have space for it, I'm going to take care of my negative exponents. The 2 would go to the bottom from the fraction. We would have the square root of x on the bottom, that is x to the negative 1/2. We would then have the square root of x plus 1 on the bottom. We would then have the square root of x plus 2 on the bottom. And then up top, all we're left with is 3x squared plus 6x plus 2. Type of thing you can do. Now let's take a look at number, or letter D. And letter D isn't a bad question, but it does illustrate a point that may not have happened too much earlier, and I want to make sure we're clear on this. So when we take it with respect to x, it's going to require implicit differentiation. And that's not a big deal. I mean, 3x squared is fine. But then when we differentiate the second term, if we haven't seen this before, I just want to remind everybody, or tell you for the first time even, when you're breaking it down into the product rule and you have a coefficient like 3x squared, keep the 3 with the x squared. It's easier. So when we actually do differentiate this, make sure you open up a bracket. The derivative of u prime, is 6x. And then y4 stays as is. Okay, so the derivative of u, and then v. And then the second one is 3x squared, stays as. And then we multiply by, or we take the derivative of y to the 4, and we get 4 y to the 3, and then y prime. Now that's going to have to be cleaned up, but I'll do that the next stage, plus 5, and then minus 0 is equal to 0. So this becomes 3x squared minus 6xy4, and then this second term would become negative, and then 3 times 4 is 12, x squared, y to the 3, y prime. And then plus 5 is equal to 0. Now the good news about this question is that there's only one y prime term. And I'm going to bring that over, so it's 12 x squared y cubed y prime. And then on the left side we have 3x squared minus 6x y to the 4 plus 5. So when we divide, we'll get y prime is equal to 3x squared minus 6x y to the 4 plus 5 divided by 12 x squared y cubed. And of course you would take a look to see whether you have any factors, anything you can do at the top. There is no common factors to take out, so nothing that you can divide from the top and the bottom. So that's basically it. So the real lesson was make sure you treat u as being 3x squared. It'll make the implicit differentiation easier. Now e I'm going to skip over. Nothing really outrageous happening here. The thing that's really interesting about e is that you have so many choices with it. But I'll leave that for now. And then F is a good question, the one that I wanted to look at, because this is another one where simplification matters. See, what you are maybe tempted to do is to take that 1/5 and distribute it in. So you get 4 to the 1/5, x to the 2/5, y to the 2/5 is equal to 1. Now use implicit differentiation. And that's fine. But what I'm going to advise you to do is, instead of putting it in that form, if you looked at it long enough, or the right way, it might occur to you, if you use an old exponential trick, by raising both sides to 5 over 1, which will eliminate that exponent, you'll get 4x squared y squared is equal to 1. And then you don't have as nasty as exponents as you would have had. You still have to use implicit differentiation. Well, actually, you don't even have to do that. You could isolate the y, but I'm going to anyways. So when we differentiate this, it will require the product rule. The derivative of 4x squared is 8x, and then the y squared stays. The second term would be 4x squared is unchanged, and multiplied by 2y, don't forget your y prime, equal to 0. So I'll keep the y prime terms on the left, and that will give me 8x squared y prime, multiply the 2 by the 4, and that's equal to negative 8xy squared. Now when I divide it out, y prime is equal to negative 8xy squared divided by 8x squared y. And we can do a little bit of simplification, of course. The 8's will divide out. We can divide out an x. We can divide out a y. So y prime is equal to negative y over x. Interesting. So an advisable way to break that one down. So I'm going to stop right there. So as I said, I called these review ones, but really in some cases they go a little bit further. And that is going to take care of it for the entire unit. So look for any sort of summary information that is released, but you've at least have covered everything by now. Thank you for your time.